Hello everyone, welcome to our game called Beam It. It is a game heavily inspired by the game called Reflections. You, as a player, have the objective of placing directional laser emitters and optical tiles like mirrors, splitters, blockers, walls on a grid, then fire the laser and watch how the beam travels, reflects, splits, or terminates. The goal is to hit targets and checkpoints with as few placed objects as possible. Our game then runs a score calculation and a star rating based on objectives hit and gives a penalty based on the amount of player-placed mirrors or splitters. Our code uses mostly object-oriented programming, which is perfect for a game like Beam It. Now, upon launching the game, you will be greeted by the menu screen. In this menu screen, you will have the option to 1. Load up and play a level of your choice. In this case, we'll give you some default easy to hard levels and some tutorial levels. 2. Open a maker mode, where you can make your own levels. 3. Read the txt file containing all the rules, mechanics, and notes on the game. And 4. Quit the game. To switch between modes, use the arrow key on the keyboard and use the enter key to choose the choice you want. I also want to mention that all inputs are all error checked in this game. Now, let us try to pick option 1 on the menu. Actually, before I start explaining option 1, I would like to talk about some important aspects of our game. Our game takes advantage of the curses module available in Python, which defines a dedicated constant for arrow keys so you can move freely around in our game. Some implementations in our game would be like these lines of code. Now, our game runs on 2 core algorithms and a coordinate system, one on reflecting the beam and one on spinning the beam. The right mirror works to change the direction of the beam from up to right and down to left. Meanwhile, the left mirror changes the direction from up to left and down to right. Now, the splitter also works to change the direction from up or down to left to right. The other important part is our simulate function, which works as the brain of the game. It does 1. Initializes variables like the beams that use a dictionary and sets a recording of the walls, targets, and checkpoints. 2. It simulates beam propagation with a DFS slack, or in simpler terms, just sets the beam's propagation mechanics. 3. Generates the beam path visualization. And 4, finally, runs a score calculation based on how many elements you place and checkpoints and targets you hit. Now, once you pick option 1, the game will scan for all available JSON files that's available via this code. It will then parse the JSON file and make a 2-dimensional grid from the JSON file with the function clampGrid. The function clampGrid uses a for loop to make sure your board is exactly max height and max width all the same no matter what you loaded. An example situation would be something like this. Also, keep in mind all the levels that you made in the maker mode will all be accessed here as well. Now, let us try to pick a level. Once you pick a level, it will record all its original elements as a set, so the code won't count the default elements as score penalties. It will then initialize a default play session state and continue to the main loop of the game. It will later call upon the draw function. The draw function functions to draw the main board, sets a priority list on the printed elements, color the actual elements, and prints a status sign so the player sees an up-to-date, readable game view. The last part of the code is reading the user input to do 2 different types of commands, one to place elements, and the other to affect the actual gameplay. Let's take place mirror function for example. The variable pref is for undoing, user added is for marking the elements is placed by the user, and user history is for pushing the undo record. Other functions like to clear a place tile, fire the laser, and undo the last placement uses an if-else try-except flow of code. Finally, it displays the score on the screen. When you pick the second option, you enter what we call the maker mode. The main idea is you can save your own levels as a JSON file and then play it in option 1. When you begin, you start the grid as a sample map and then normalize it to a 20x20 grid. You then enter the maker mode loop. In the loop, it uses the same draw function, but this time you can delete elements by pressing space and then add any elements of your choice. Then at the end, you press the S key to save the level as a JSON file with the following timestamp JSON file and exit the loop. The rest of the options like the readme loads up the readme file in the terminal and exit function to exit the whole program altogether. Thank you for watching our video and have a great day.